Good afternoon, good morning, and to some of you, good evening. A warm welcome to our global audience. Thank you so much for being with us today for part 2 of our 3-part webinar series on PTP ST 2059. Hopefully you were able to attend our first session last week, in which case, welcome back. And if you missed that, look for the recordings to be posted soon. And thank you for being with us today. We really appreciate it. This is our second session with our focus on PTP architectures and best practices. And the webinar series is, of course, presented in partnership with Telestream, Imagine Communications, and Arista. My name is Gina Angelia, and I'm part of the marketing team at Imagine Communications, and I'll be working behind the scenes today to help out, along with several other outstanding experts from Arista, Imagine, and Telestream. They're here to help answer and moderate questions, as well as engage with you, our audience. So just before we get started, I do have a few small housekeeping items, and I have a slide that will go over some of that for you. Now, on one technical note for you, please be advised that if you're currently connected to a VPN service, know that it may impact the quality of today's broadcast. So we do recommend that you disconnect from any VPN service for the duration of the presentation if that's possible. If you're having audio trouble or are concerned about your connection quality in general, a reminder that a list of regional dial-in phone numbers was provided in your registration confirmation email. For those of you who may be new to the Zoom webinar platform, there are 2 key buttons I would like to draw your attention to in the application. You should be able to move your mouse cursor to the bottom of the presentation window, and you'll find them there. The first is our chat window, and that's where our team will be posting any important messages should the need arise. And if there's any technical difficulties, we will likely come to you in that chat window as well. And second, and probably more important, is our questions submissions button. We welcome everyone to add their questions to this box at any time during the live broadcast. We have a fantastic team behind the scenes that'll be following up with questions, and they'll be here for you as well. So speaking of our panelists today, we have 3 keynote speakers with us, as well as a few other experts behind the scenes, as I mentioned. And they're all going to be part of the broadcast today. But on air, you're going to be hearing from Mike Wadeson, who's an application engineer from Telestream, Lee Whitcomb, architect at Imagine Communications, and our host for today is Robert Welch, principal engineer from Arista. To everyone on our panelist side of the call, we really appreciate you being with us and taking the time today. And once again, thank you to our audience for joining us. And with that, I'll hand it over to our presenters. Robert, the show's yours.
Okay, thanks, Gina. Thanks for the great introduction. And indeed, this is a live webinar, so please use this time to ask questions. There's a couple of warnings. I may start to talk fast. I apologize, but you will have the recording. We're going to go through a lot of material here. There's more material that we can actually cover in an hour, to be quite frank. So just note that, there's a lot of information. If you don't understand some things, it's okay. We'll get the replay. But if you really like to get some hands-on, Arista does have a free test drive. We call it the ATD Arista Test Drive. And that's for you to get your hands-on virtual switches. It's a training class. So again, welcome to this live presentation of PTP architectures and best practices. This is, again, part of a 3-part series to help you get familiar with it, but also understand the best practices. Just a bit of a note on terms. So during the course of this webinar, we're going to be using terms called master and slave. And those are the nomenclature that we've used in the standards bodies for IEEE and SMPTE for a number of years. Those are in an evolution. They're like everybody else. You may have heard, for example, that Twitter has changed to leader follower. And we're doing the same thing. We're just doing that in the right way to make sure that the industry is in agreement with these terms. So we're going to move forward with what we want to do first, which is talk about best practices. Now, when you talk about best practices, you have to start with a baseline. And everyone has a different network topology. There's no 2 that are alike. If there were, then it would be very much easier, but it's like with any broadcast facility, there's a specific purpose that you're trying to achieve with that network. On the left-hand side, for example, you could have a spine leaf environment, and that's all connected. Everything is purple connected. They're neither amber or blue or red or blue, but everything is fully connected. On the middle there, you've got a spine and leaf, and up at the top here, you've got spines, if that's a new term. Think of that as your interconnect. That's your interchange to everything else. And then you'll see that you have a spine for blue and a spine for red. This is what we typically call the 2022-7 network with amber and blue. We call it A and B sometimes. Or you may even see some nomenclature called green and blue. But just note that the two colors designate 2 distinct networks. that are not connected together. There's no media flows that go between the two. And on the right-hand side, instead of using a distributed architecture, there's a monolithic switch approach. And so you as an organization have to figure out which one of these or combination of these is right for you. So we're going to step into best practice number 1. Get the right equipment in there first. Start with the equipment in mind. Think about the scalability that you need for your devices. Do you need 400 gig? And yes, there are many people that are using 400 gig. There's 100 gig that's out there as well that many people are using. For example, the Imagine SNP, just calling out Lee with Imagine. This linear network processor has 200 gig ports on it. There are some mixers out there that have 800 gig ports on it. So think about that in mind, but also think about the tenets of not just building it, but getting PTP right. So your first best practice is choose a switch vendor, or product that actually scales to your needs. PTP has to be working. It's the foundation for everything to sync. It's no longer black burst or tri-level sync. PTP is the way to do this. And you'll see these little deltas along the way. What we're trying to do is put PTP in play in every little link in the network to figure out what that offset for master is, what the actual time is. Remember, the clocks are running up here. The grandmasters are running up here. And down below, what it's doing is it's feeding each one of the different switches. And we'll go into what each one of these means as a grandmaster, transparent clock, boundary clock, and ordinary clock throughout this. So this is going to get used to some terms. Now, you may remember, if you watched Mike's presentation last week, was it last week or 2 weeks ago, Mike? Time flies. Is that you have to set your domains right, your priorities right, and all that stuff too. So best practice number 1, though, is get a switch that's going to be scalable per broadcast and for your engineering needs, okay? So just a reminder about these different types of clocks. An ordinary clock is more like a media node clock, an end device, a receiver. This is what they call, basically, it's a slave device. Transparent clock is a means by which we're updating the time as it traverses the ASIC on the switch. Literally the ingress port and the egress port, that time, that variation, the nanoseconds or milliseconds it takes to go across that particular ASIC is calculated. And it's calculated for every port. And then boundary clock is similar to transparent clock where it does the update. The boundary clock is the regeneration mechanism. So the regeneration means I'm going to be now your master to slave out the traffic. The PTP comes from me, the switch, versus transparent clock, and we'll go into more detail on this, versus transparent clock, which is coming from the grandmaster. But in both cases where transparent clock originating from the grandmaster or boundary clock, that timing is always updated. And we'll get down to the factors. So just by way of review, let's just kind of go through grandmaster at the top. Grandmasters, you put multiple in, and they'll do a BMCA, Best Master Clock Algorithm. We played a little game last time called BMCA to figure out which one is the right priorities. So you want to make sure you get the priorities right here on the grandmaster, but also get the priorities right on your boundary clock switches as well. What should that priority be? What should the domains be? What should the failover be? Now, consistent across this whole thing is domain. If you don't get the domain right on the switches and on the grandmaster, you're literally talking ships in the night. The switches aren't talking the right domain. They're not talking the right grandmaster. And that's not good for your environment. So consistency test number 1 is get your domains right. Now you can pick a number, and that's always a good idea to pick a number, not the default, so that you know what your plant's domain number is. And sometimes you have to configure that even all the way down to the ordinary clocks on that side as well. So just to know, just the top level section here, you got your grandmasters. We've got a transparent clock, and we'll go into why we have a transparent clock here. That's part of our best practices we'll get into. We have boundary clock where we're regenerating. We are becoming master ports to these slave devices, okay? And up here, what we're doing is this particular switch is slaving off of this grandmaster, which is the primary. And right here, again, to talk about the E2E transparent, this is just updating those management messages going across it. So we'll go into more detail on this, but I just want to kind of reintroduce you to what we did in Mike's presentation, that 101 class that we took, okay? So again, in best practice number 1, choose switches that can do boundary clock and transparent clock. And you choose something that actually works and scales. People tend to put like switches, I'll call them dumb switches, off of existing ports like a boundary clock. Well, these ports aren't meant to carry more than maybe a couple of endpoints. So if you put a switch down there, let's say a 48 port switch, now you've got 48 end nodes, media nodes, ordinary clocks that are trying to slave off of one port. And that's not good. The other not good is, if I can use that term, is, as you can see right here, there's no way to actually analyze what's happening on the switch, if it's just a jump switch or not even manageable, to see what that clock accuracy is and to see if it's actually causing jitter. So there's no sense of priority on here as well. So stay away from anything that is just a regular switch. Switch stacks, for example, tend to break apart with large multicast. PTP is multicast. It has to support these things at scale. So what we're trying to build is a best practice solution where you have your grandmasters that can do your BMCA and also have updates on all your points of entry. Every link has an update, okay? So that's point number one, which is get it right, okay? And if you get it all right, you're not gonna have as many problems. You won't have to worry about what PTP is doing, and you can start from there and really build up very quickly, but you have to get that right. So let me kind of go through what's happening from a PTP perspective. You'll have on the left-hand side, and this is going to be a boundary clock enabled switch here. We'll enable the ports for boundary clock mode. You'll have the grandmaster that talks distinctly to the switch, and then you'll have your end nodes that talk distinctly to the end nodes. So this particular port is going to have a slave device off of it. So you'll have these announce messages, you'll have these sync messages, a follow-up message coming from the master, and you'll have the delay request coming from the slave, and then delay response to figure out what that delta time is. This whole method, this happens, in fact, I'll show you the numbers on this, sync and follow-up delay request happens 8 times per second. 8 times per second for the sync, follow-up, delay request, and delay response. Get that? So that's pretty heavy. IEEE 1588 is less stringent. It's not as stringent as this. We really want PTP to be the timing mechanism that you can rely upon for your broadcast environment. So this is why we chose from a 2059-2 profile to be these values. We've also done some work with the AS6070 team, and we've unified or harmonized the numbers. So 8 times per second on these, and then once per second on the announce. Oops, this should be pushed down just a bit. This is once per second, and these are 8 times per second. Okay, so best practice number 2 is use the SMPTE PTP profiles all the time. Number 1 is if your end node is expecting the 2059-2 profile, then you better be on the same profile that the switch is at. And the switch better be on the same profile as the grandmaster, and all domains should be consistent. So that's best practice number 2. Okay, best practice number 3 is this thing we like to call PTP role master. This end device, this end node should never become a grandmaster. So how do we protect that port from actually becoming a takeover port or somebody plugging in another grandmaster or something like that? We use this nice little tool called PTP role master to force that link to be master only. And then on the other side, we just don't put any role at all. We put the right PTP delay request, delay response, sync and announce intervals, all those types of things in there. But we don't put any role on this because this may be master, it may be slave. It's all based upon what BMCA is. Whew, hopefully you guys are keeping up on this. So again, left-hand side separate from the right-hand side, we regenerate it. How do you verify on the switch? The switch is a tool by which you can get diagnostics from. Unlike, basically DAs or something of that nature, you really want to have the switch that gives you information. And we'll just kind of walk through some of this stuff. So clock domain 42, because that's what we chose, 42. That's the configuration on the switch. So we verify that that's 42. And it must be consistent across the thing. The clock identity that's being shown here is the switch itself. So you can verify that on the switch. And the clock class is 248. 248. You guys remember the last presentation that we did? What does 248 mean? You guys remember?
It's handset. So that means it is internally locked.
If it was actually a grandmaster, the number could be what, or should be what?
If it was locked to GPS, then it would be a clock class of 6. And if it was locked to GPS and in a holdover mode, it would have a clock class of 7.
And see how the numbers, as Mike was talking about, the numbers go higher, which means less accurate. So 248 is the default value. So the switch, since it's not locked to anything else, he's going to run at 248. So that's always right. Now, there are some switches where we have grandmaster clock capability on it. It's kind of few and far between, but there are switch and switch vendors that do that. Again, security mechanism, and all the best practices associated with that. So this is one of those trust and verify things. The other thing you can get from switch is, hey, by the way, what's the real grandmaster ID, the clock identity for that? Your grandmaster, and when it does a BMCA, the grandmaster numerical value, it's more like a MAC address value, that will change. If you look at your entire facility and you do a show PTP, for example, and those grandmaster numbers are different, you've got a problem in your communication. Maybe multicast isn't working right. Maybe you've got another grandmaster that's local to the switch versus something else. Or maybe you set your domains wrong and you've got a grandmaster with a different domain and the switch is on a different domain. But you want to make sure that that's completely accurate across the whole board. Now, just looking at the ports, you'll see the different states here. I'll just go over that real quick. Disabled means I enabled PTP on the interface, but the port's down. As soon as the port comes up, I'll start sending sync and follow-up. So as soon, let me say that again. As soon as that interface goes up, I start sending sync and follow-up. Okay, I'll go over that a little bit more. And there's always one slave port on the switch, and that slave port points to, in this case, Ethernet 48. This must be Ethernet 48 because I'm locked to that grandmaster right there. So right away, you can tell whether your topology is working right or not. Now, let me show you what can go wrong. Some devices have to be kicked. They have to start their PTP agent on the end device. Well, how can you tell if PTP is actually kind of pseudo working right? Maybe it can't check the domain or something like that. Well, you'll see this delay request, delay response. If this does not initiate a delay request, I don't send a delay response. I'll always send sync and follow up, so will the grandmaster, but you will see something like this. The messages received are 0, and the responses to those are received are 0. This means that this device, this particular gateway, is not really sending PTP. It's not participating in PTP. So maybe there's a configuration issue, maybe there's an upgrade of firmware that you need. So here's a quick way to determine from your edge device whether or not it's kind of working. So we talked about in a prior slide where you have these, I'll call them just ordinary switches, non-PTP aware switches. You want to stay away from these because the complexity is off the charts to try to get these to work. Can we get it to work? Yes. Should you do it? No. Stay away from it because it is a nightmare to diagnose, nightmare to configure. Here's just a few points. One is, remember I was talking about the grandmaster up here, and then it talks basically boundary clock right here. This port right here is going to punt all PTP messages to the CPU. We have to handle all this PTP and CPU to handle all that update traffic. Well, if all the traffic is being sent to that PTP port, well, I can't get to the grandmaster directly. So what ends up happening is you end up flooding all that multicast to all the other switches, number one. Number two is your rendezvous point you can't get to either because it's going to the 224.0.1129, which is PTP, and that is not going to be available if you're punting it to the port. So what you have to do is put local rendezvous points for that particular multicast address on each one of these switches. Maybe it doesn't even support multicast. Maybe it's just a dumb switch. So therefore it won't work at all. But there are some tricks that you can do to get these things to work. But again, it's not tenable. It's things that you don't want to do. It's not a best practice. The other thing that comes up is, well, why don't I just use the grandmaster itself? Why do I need to have a boundary clock switch at all? Well, let's kind of go through that a little bit more. So let's just say we're multicast, we're not updating, we're not transparent clock, we're not boundary clock, we just have a dumb old switch. Well, the announce messages go out, sync follow-up, remember 8 times per second, and that will cross the switch. This will be multicast or IGMP. So you have to think about what's the scalability of that grandmaster. Is it 1,000 endpoints? Is it 2,000 endpoints? How many endpoints can that thing receive? And notice I'm not doing dual over here. I'm not redistributing. I'm not originating these messages over here. What's happening is I'm losing that opportunity to diagnose this type of stuff too. But what could end up happening is this device goes out of sync because of all this other messaging that's going on. So you want to at least prioritize QoS if you're going to do this. Again, not a best practice. Well, what you don't realize though is because it's doing a join for 224.129 for all the endpoints, that's the multicast address for PTP, you run into a situation. For example, you've got your camera here on the left and you've got your microphone here on the right. They both join PTP 224.0.1129. And so the grandmaster sends the sync and follow-up message. Those go down, they're joined. Then you get your delay response, delay request, and delay response, delay request. What's happening though is multicast is because it's all going to 224.0.129 is going to send those delay requests, the response, all the way to the microphone and microphone to the camera itself. Wait, say that again? Yes, that's right. The microphone will hear these messages from this particular camera and vice versa. So if you do this in large scale, you've got all these extra messages that are throwaway messages. So in a 40 slave environment, you'll actually get 624 PTP messages per second that you have to throw away. If you've got a low-end device, maybe a mic or some endpoint that just can't handle this amount of messages, throw it away, you're just creating more havoc. So the best practice is, again, use boundary clock. Don't use something that is not going to regenerate in scale, and realize that your endpoints are going to suffer if you just use multicast, and you have no diagnostics either. So again, what were those numbers that we were talking about? The announce was once per second, sync and follow up 8 times per second, delay request, delay response 8 times a second. So that's 25 messages for every second. And a switch with 300 slaves, that's about 7,500 messages altogether. Imagine having one just big network with all just multicast. That's a lot of packets to throw away. So what we want you to do is really do it differently and have boundary clock everywhere. The other question comes up is, well, if PTP and scalability grandmaster is an issue, why don't we just add another grandmaster and put another domain out there and split them up? Well, again, this is multicast. You're going to just exacerbate the issue. You're going to still get all those messages, and it really doesn't help you with the original thing. Now, remember, you always want to have a single grandmaster as your single clock source. What if one of the, like domain 44 comes online and it's not as robust as domain 42? So now you've got different PTP that you're trying to lock to, and that's very difficult to support. Now, we do see this in tricks in some installations where people just add more PTP grandmasters, but that's not the way to do it. If you want to add more resiliency, just put 42 on both of these, add more grandmasters, let one of them actually do the BMCA and be the primary, and forget all this nonsense about multicast. Okay, but just to note though, transparent clock is basically using multicast as a mechanism. Remember, I'm not regenerating in transparent clock. I'm saying boundary clock regenerates, transparent clock doesn't. So you do have this multicast issue if it's a transparent clock. So you want to have boundary clock, not transparent clock. So let me say this in a different way. You still have that multicast issue. At least the time is updated, but you don't regenerate. So this is one of the things to consider right here. So Lee and Mike, am I going too fast? Is this resonating? And tell me what your thoughts about transparent clock versus boundary clock at this point.
Yeah, no, I think you're going at good speed there, Robert. Yeah, so just understanding on the transparent clock is basically a boundary clock. If you're looking at from a median node's point of view, with a boundary clock, it's the only device on a port, and so it doesn't see a lot of traffic. So it's sort of good for that median node. If you have a transparent clock, even though the timestamps are updated, so the timing is a bit more precise, you still have sort of that n squared problem where you're seeing the traffic from all the other devices. And so a transparent clock still puts a lot of load on those median nodes. And so you have this poor audio microphone, which is getting 1,000 messages per second, may not be able to keep up. So definitely our best practice is having those boundary clocks at the lowest level. So if you're connecting a median node, you should really only connect a median node to a boundary clock.
Mike, do you want to weigh in on that?
I totally agree. You should use a boundary clock for all the media nodes, and that way you take the strain off the grandmaster, and so it's kind of working, but it doesn't want to be working too hard, and you let the loading be handled by some of the switches, and then they're going one-to-one between the switch and the media node and not really talking to the grandmaster, and that makes its life a little easier to deal with the important stuff of keeping time.
Yeah, you know, it's do one thing, do it really well. That's what my grandmother used to tell me, and I'm like, okay, I don't do anything very well, so I have to pick one and just work on that. So in this particular case, let's just switch boundary clock, just be the boundary clock. Let me use the grandmaster, domain 42 grandmaster here that's got the BMCA and it's got clock class 6 on it. Be whatever it needs to be. By the way, the other thing to think about too is not only locking to the same grandmaster here for PTP, but remember this other one we were just talking about before? Well, if you have a facility that needs black purse or tri-level, these devices have all that capability built into it. So if you're doing this, where would you actually put your tri-level or your black burst? You want to connect it up to one single point. This is why we keep talking about having a single infrastructure, a single source of reference for everything in the facility.
Yeah, and Robert, also another advantage of then using the boundary clock too is it, from it comes to a debugging point of view, it's a little bit easier to debug the system because you've got basically your media nodes only seeing messages from one device. In the transparent clock case, you're seeing the messages from all the other devices, and if something goes wrong, one message sort of causes something to go wrong, which causes something else to go wrong, and it can make the debugging also very challenging. So when you're coming to sort of commissioning and debugging and troubleshooting, the boundary clock sort of also simplifies the problem. It compartmentalizes what's going on.
Amen, brother. I mean, I can't tell you how many times, like during the interops that we all worked on it, we're trying to analyze what's going on for a particular endpoint, and we're doing Wireshark or we're doing TCP dump to the switch itself, and we're just trying to look at those particular messages. Well, if everything is 224.0.129, you have to capture all that and then dig in deeper to figure out, okay, what was the delay request, delay response to that particular endpoint? So, like you said, Lee, troubleshooting is just off the charts when you try to do it. Okay, so best practice number 4, moving right along, and I think we have about 10 best practices, so we're up to number 4. So we have a transparent clock here. We've got boundary clocks here. The idea that is the best practice is to use transparent clock at the feeder leaf. We'll call it a PTP feeder leaf, for lack of a better term. And what we'll do is we'll put all our grandmasters on there. Obviously, you want to have some redundancy here. This is just a high-level example. You typically want to have a boundary clock, transparent clock switch that connects to Grandmaster 1 and one that connects to the other, and then it feeds into the rest of the network. But one of the benefits of having transparent clock here is you can do things like with a prism. Prism scope can look at the PTP messages coming right off the Grandmaster, versus if the prism was connected down here, he would see those PTP messages as in a boundary clock mode, not necessarily from the Grandmasters themselves. So there's additional debugging capability that you have when you stick it up here. So best practice number 4 is use transparent clock that feeds into your boundary clock switches. So this will be your distribution amplifier, if you will. And this also allows for faster BMCA, to be quite frankly. There's no thing called a holdover mode, which we'll get into in a bit. So quick BMCA, we can capture that, and then it's fed down. Lee and Mike, you want to weigh in on this at all, the transparent clock, and why this is the best practice?
So the transparent clock is adding a correction factor to the information that how long it's taken for the message to come into the transparent switch to going out of the transparent switch. So it accounts for the media node at the end, can take account of that delay in its calculation of time. So that's why you would use a transparent clock.
Yep.
Good point.
And also just sort of weighing these. I mean, it's definitely just helps some of the debugging and stuff. If you had to make a choice though, like the previous rule of the boundary clock before the media nodes, that's kind of a super critical one. So that's a best practice you really don't want to violate. Depending on your design, there are some designs where you may not want to put this transparent clock there. You may want to use a boundary clock. It's kind of will depend a little bit more on your application.
Yeah, and we'll get into that in just a little bit. So if you did put boundary clock in the mix here, by the way, this is not necessarily spine leaf. I'll show you some more designs, some real designs as you just get through the terminology by way of example. So if this is a boundary clock and we do have a BMCA event, let's say we actually lose our antenna here, we're going to do something called, the switch will do something called a holdover mode. So he wants to make sure that indeed this is off. He's going to listen for a bit to make sure that this is the new Grandmaster, and then flip these two from a slave port here to a slave port here. But you can see this is actually from one of the logs that we have on the switches during one of the tests. Is you'll see that the Grandmaster ID actually changes. Again, remember that Grandmaster ID? That's going to be that MAC address associated with the individual device. So you want to maintain that information somewhere of who is the Grandmaster. But as long as you've got resiliency, it's almost who cares. But you want to have some type of control at least. Okay. So to note though, there's a bunch of port states that happen when the Grandmasters flip if this is boundary clock, and so we tend to stick to those. But again, this switch is not meant to be the originator. He will basically free run during this time of BMCA, and he determines when the other one's available and online and locked. But there is a holdover time, but that clock is not as accurate as the clocks that are built into these particular switches. So what does that mean, not as accurate? And so just to give you a sense of what accuracy means, you really want to be holding to a device that's like 10 to the minus 6 or better. So have a crystal in there, have the tools in there, have the MES messages, TOV messages, all that stuff coming from an authoritative device. The switch itself may not be authoritative. And that's actually written into the standards, right, Lee? I mean, we spent quite a bit of time on the 2059-2 group talking just about this.
Yep, because I mean, the thing to remember, and this is sort of a little different between different industries, but our grandmasters are ultimately feeding the media nodes, and the media nodes have to create video signals. So we have to make sure that our grandmasters are good enough to basically create video signals within the specifications are required there. So that's where this sort of 5 ppm number came out from.
Yeah, and if you can afford it, go ahead and buy yourself a cesium standard clock and 10 to minus 12, and you can, forego all the GPS stuff. Very expensive to do. But if you have that kind of money to throw away, sure, why not? There are other grandmaster types that are coming out. You'll see different form factors of things. There's also some discussion about, hey, do I get something from Blackburst and then update PTP? And then the reverse of that is, hey, I want to get PTP in. I want to be receiver PTP in and then serve Blackburst. There's a lot of ideas floating around about the feature sets of what PTP is going to do and the back and forth between the different inputs, if you will. But GPS, if GPS is the choice that you have, then do that and do that for your entire facility. But again, it's locked to one thing and it's very accurate. Okay. So we get this a lot when we're talking about Dante and Ravenna and these small network type of things where you just need to stand stuff up. You'll take a switch out of the box. It might work for a while, but eventually, like for example, I had a situation at a broadcast company where they had a bunch of IRDs that were coming in and they were about 200 megabits per second. They would add like their 10th one and then nothing would work. So what that ends up doing is without something called an IGMP snooping querier, your multicasts turn into broadcasts. So you need a snooping querier and a snooping query address to turn those multicasts into multicasts, which means somebody has to join that flow. Now, we don't have time to go through what multicast and IGMP is in this 1 hour session. We'll have a follow-up session on the multicast and IGMP in a later webinar. But just note that without doing this on your switch, every multicast is a broadcast, and that can overrun your switch. The other thing to note is if you're cascading switches together, there's this, they'll do a tiebreaker to figure out which one is actually the querier. I think of it as the mom. Mom's out there going, hey, do you really want this multicast address? Do you still want it? Do you still want it? And it does the cleanup. Mom is also out there. The IGMP snooping querier is out there to really program the switches themselves. Okay, you just did a join. You need this particular multicast. I'll tell the ASIC, plumb that traffic directly to that. So without these, though, this is all flooding. Note, though, that if you have two switches cascaded and they've both have multicast enabled, IGMP snooping query to query address, the lowest number wins. This is just L2. And what it has to happen is the non-querier switch has to flood all the multicast traffic. So remember we just did this to turn off all the flooding, all that turning the multicast into broadcast? Well, if you cascade a switch, all that traffic has to cross the link because I need to tell the left side needs to tell the right side about all the multicasts that's there. So you fixed one thing, but then you broke something else. Is there a solution for that? So best practice number 5 is turn on IGMP snooping querier, give it an IP address. Without an IP address, it won't work. But if you need to have some type of control, best practice number 6, if you're forced into doing this, then do something called an IGMP snooping querier address of 0. And this is in the RFC 4541, which is a special type of querier which doesn't flood. What it does is proxy all that update information over. So now I'm not flooding all that IRD traffic or MIC traffic or anything else, which may have an effect on PTP, by the way, because PTP is also multicast. What you'll end up doing is the switch on the left will tell the switch on the right, hey, I know about these multicast addresses because these guys are transmitting. Okay, so you want to get this right. You have to get the network right, and you have to figure out this flooding. Now, I would put a best practice 6B in here, or 6A, which is say, if you're doing this, it's not really the best way to do it. I would say that you really want to do routing on this and see if you can get by with just doing something of this nature. You have a subnet on the left and a subnet on the right. And in this case, only when you have joins that cross, for example, if this mic needs to go to this multiviewer here, it just does a join. This guy right here, the multiviewer does a join, it says, send me that. If it needs to do a join for the camera, great, the multiviewer does a join for that, and only that traffic goes across for that particular, that feed. So this is much more efficient if you do routing. It's also much more scalable. You don't have issues with spanning tree loops. It allows each one of the switches then to become what you could be basically a grandmaster, or at least a transparent clock. So get the networking right, get your multicast right. Now, the other thing you'll hear about sometimes when you turn on routing is, hey, I'm working on this switch and I can do all my joins okay, but when I try to do a join over here, I can't get to it. What's wrong? It's your stupid switches. They're not right. What it is you look for this thing called a TTL equals 1. Think of this as your toll booth. You have to pay a price. You decrement that TTL every time you cross a layer 3 boundary. So we recommend at least a TTL of 16 for your essence flows. That is a best practice, and stay away from anything with TTL equals 1, which means literally stay on that switch. So again, if you get one of these situations where I can actually join on one switch, but you can't join on the other, that means you probably have your TTL set wrong, and you probably have your multicast routing not quite working right. So just to know, and by the way, everybody who's listening right now, you know about routing. Everybody at home or at work, if you're able to get there, is doing routing in some way, shape, or form. If you go to a Starbucks, which I guess you can do now, they're using routing as well. You'll get a new IP address, you'll get a gateway. So just get familiar with what routing is and what IP addresses are, and it'll become familiar to you. Okay, so let's take a step back and let's look at some real architectures now that we have the basics. Okay, on the top we have a spine leaf environment. We've got our amber and blue all separated out. We've got our multicast all working. In the bottom one, we have our monolithic switches. Notice they're separate, they're air gapped, much like the amber and blue. So everything's working. Be cognizant of the amount of traffic that each one of the links requires. You don't want to put maybe 800 gig devices here and then need 800 gig uplinks here. You want to figure out maybe it should be a larger switch. We can work with you on what the right design is. Okay, but you want to be consistent about some certain things. Protecting PTP, packet pacing, things like that. So where do you put your grandmasters? In the monolithic switch environment, what you'll do is put one on the left side, the blue side, and put one on the right side, the red side, or amber side. And you'll do this thing called a PTP only link. You don't want to actually advertise multicast across this. You don't want to use this link for anything other than making sure time is consistent in the environment. Same thing is here. You might add, as we said before, a grandmaster connected to one switch, another grandmaster connected to another switch. These are transparent clock switches. We have very fast BMCA. They can talk to each other, and then they feed the rest of the organization. So these are our spines, and these are basically PTP feeder leaves. This is a best practice number 8. So move along and figuring out, where do you need to put these? You want to make sure that they're redundant, that they can talk to each other, that you've got the routing right, and that you've got consistency across the whole thing. But make sure that you're doing it in a way that you're not exposing routes between the two. So that may sound like, okay, gosh, you're getting really networking geeky wise. The next thing you're going to bring up is access control lists and how do I filter this? No, we actually have a solution for which you can do this very easily, very, very easily. You have your 2 links on the left side and right side. You might put this port over here on VLAN number 666, put it on VLAN number 666. It doesn't go anywhere, and it just passes PTP. And then you put another port on 667, VLAN 667, goes on both sides, and then allows for PTP. That VLAN is just there for a layer 2 connection. You could almost think of it as a shunt connection from the grandmaster through the switch over to the other switch to the grandmaster. So it really is just a shunt connection between the two. Okay, could this particular grandmaster also be on 666? Sure, if you want to. It could be a routed port if you want to. It doesn't matter as long as you're just protecting this link from servicing actual traffic between the two. So that's idea number 1, is just have a VLAN. The other idea And for those of you who've actually configured a switch before, you'll understand this. We'll have to have better examples in the future when we go into more detail. Is option number 2 is to create a routed interface link on both sides, but don't put an IP address on it. So instead of it being a switch port, it's a routed port, but there's no IP address, which means I can pass packets, but I'm not routing. There's no ACLs involved. So you go in on that particular interface, you say no switch port, which turns it into a routed port. You don't put an IP address on there, and you do that for all 4 of these ports. And bada bing, bada boom, it just works. No fancy ACLs. Things can talk back and forth. I know, Lee, is this too geeky for you guys? I mean, does it sound like it works? I mean, and then also there's other people on the phone, Ryan and Gerard and others that have actually done this. But Lee and Mike, what are your thoughts so far?
Yeah, so one thing also maybe to make clear for everyone is when we're using the amber and blue networks, that's basically 2022-7, which is one way of doing redundancy. And sort of note that that redundancy is different than how PTP does redundancy with the BMCA. And that's why I just want to emphasize that it's very important that both your red and blue or your redundant networks there, they all must converge to the same grandmaster ID. So where your essence traffic, we effectively want to sort of air gap and keep those separate. From a PTP point of view, we want to keep those 2 networks connected, and so they're all converging to only one grandmaster. And actually in SIMPTE, we have I'm working on a sort of a recommended practice or a standard to help sort of explain and describe the rules of how end devices work under this sort of situation, because it is a little bit unusual having these redundant networks and BMCA all working together.
Yeah, there was a question that came in. See if I can actually do this live. It's on this slide here. So the question was, can't I just use an ordinary switch up here that does multicast? And the answer is, well, remember, you want clock accuracy. So you want to know what that delta is to go across. So the best practice is to use transparent clock so you get that update that occurs between these 2. Could you get away with a dumb switch? Yeah, but again, you're losing that visibility into the switch. You're losing that update, and you're making the, basically the downstream switches. In this case, happens to be the spines. These are they're basically PTP feeder leaves. These leaves feed these. You want to have accuracy at every point in the network. So don't use just a dumb switch up here.
Yeah, and a couple of other things too. I mean, going back to that debugging, the switches have counters and various monitoring things which you lose. So when it comes to troubleshooting, it becomes harder. You don't get that compartmentalization that you do with the boundary clock, which isolates the traffic. So using those sort of non-PTP switches, while maybe saves a little bit of money, will cost you a lot of pain when it comes to troubleshooting, debugging, and when failures occur.
Absolutely. And again, multivariant, whether it's spine leaf and maybe, you have your feeders up here, or connecting directly to the spines themselves with that PTP only link. So your options are pretty much endless once you have the idea. Sometimes people say though, that this is it's a bigger switch. I only have QSFP ports. I want to plug in my 1 gig. So I'm going to burn my QSFP for 1 gig. Maybe a couple of them, because these grandmasters not only have a PTP port, there might be a management port and an NTP port. There might be multiple ports. So how many interfaces are you burning on your spines? So that's why we're recommending like the leaf approach, is so you can plug all those copper connections in. Okay. But one could so say, I'm going to plug my PTP port into this port here, and I'll plug my management and also NTP on another leaf. And that's perfectly viable as well. The main thing though is get PTP right, and don't allow the connection between your amber and blue to go across those links. Otherwise, everything's purple. I mean, everything can get to everything. So back to this. This is really the best practice here. Have your PTP feeder leaf, know where it's going, figure out that your masters and slaves are right, get your domains all right, and get PTP working day 1, okay? Don't leak routes. So the other thing to consider is, and this is a much longer discussion, we want to make sure we have time to kind of dwell this out a bit, is, well, that's great for one site, but I've got 5 or 6 sites or 2 sites. Do I need a grandmaster pair, because you want resiliency at each site? And the best practice is, yeah, you do. Do you put PTP over the WAN? Potentially. I mean, this could be dark fiber connections. They could be all in the same domain or separate domains, depending on what that resiliency is. but sometimes you might have an MPLS or a lit circuit or something like that that doesn't allow for PTP.
Hey,
so you want to make
Robert.
sure that, yeah, go ahead, George.
Sorry, we've had a few questions about what the P means. Is it worth just popping back and clarifying that?
The floor is yours. Tell me.
I'm not going to talk about it. You can do it.
No, please, Gerard, you're wonderful at. Plus, you have a nice accent, and it sounds better.
Okay, sure. Yeah, okay. So we've had a few questions about what the P means in the context of this diagram. So in the context of this diagram, and using the old terminology, S is for a slave port, something that's locked to an upstream master. M is a master. You'll see the P ports are in places where, if you were not careful, you would have a PTP topology loop. So, for example, between anywhere that there's a P, it's breaking a loop in the PTP topology. So it means passive, stands for passive, and it prevents that PTP loop. I hope that covers that.
You can think of it almost like spanning tree for PTP, huh?
Yeah, and maybe just to add, I mean, where you would often see this is like if you had two links between switches, then one link would be operating in that passive mode. That's sort of an example where you might get that.
Yeah, both of them can't be, because remember, on every switch, there's always going to be one slave port, and it goes master slave, master slave, master slave, and then master slave. So it's an MS, 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 MS. So you can think of it like almost like a waterfall of MS. And then the P are the alternate links that aren't used, but are standing by. So for example, just picking on this blue leaf switch here, if you happen to lose this link, disconnected, somebody shuts it down, it's a bad day, the transceiver got pulled, somebody stepped on the fiber, whatever it happens to be, this P will then become the S. Gerard, did that answer the gentleman's question?
I think that's a good explanation, yes.
Okay. Right. Very good. So a lot of things to consider here on this, and we want to make sure you get to some of the questions that are, have come in live, and we have a little bit more banter about what it is that you'd like to readdress here, because we want to make sure we get to the material. All this material is being recorded. You will get the slides. It'll happen in about a week or so. But this is one of the hardest things that we've had to deal with recently, not because it's difficult to do, but because there's so many different variations, as I showed in the first slide. You may have in one site literally just two switches, in which case you might want to have purple meaning that everything can connect to everything. You may have a whole spine leaf architecture here. You may have OB trucks that have redundant monolithic switches. So how do we do this is rule number 1, or best practice number 9, is site resilient GMs. So at least make sure, in case you get isolated, like in a disaster recovery situation, that you've got grandmasters local to that environment. So Lee and Mike, what are your ideas, or what do you think about using the same domain or different domains for each one of these, or even filtering out PTP at the WAN edge?
Yeah, so when you're going over the WAN, you want to keep each island somewhat separated. So using its own domain is definitely one way to do that. You can also you could have both of them on the same domain, but then just make sure that you don't have any sort of PTP traffic that's spanning from one of your islands over to one of your other islands.
Keep it isolated.
Keep it isolated, yeah. And also be careful when I'm talking about islands here. We're talking about things which are like an OB truck, which is far away. I mean, if you're within a building or something, they should all be connected. This is just when you're dealing with something which is spread across campuses or far distances.
New York to New Jersey, for example, California to Sacramento, whatever those connections might be, if they're longer distances. It also depends upon the workflow too. We've seen situations where you'll have your vision mixer up here and maybe your other devices up your playout systems, but down here, all you really have is mics and maybe cameras. So all the mixing is going on remotely. And in which case you probably want to have PTP or have a solution, a WAN solution that allows for PTP to go across. So it really depends upon what your requirements are and what the workflow looks like and how much bandwidth is required. We've seen where a lot of people are picking up 400 gig or multiple 400 gig. We have Arista just happens to have a 16 by 400 gig in one pair of fiber option. So all that muxing is basically just allowing you to have more bandwidth between the sites. So, but not everybody has that luxury of having dark fiber. So your mileage may vary. And this is one of those ones we have to whiteboard and really understand what it is that we're trying to achieve. And is it dedicated only to your broadcast network, or are you sharing it with your IT network too? And that's another issue that could happen. So we'll do a dig in, we'll do a deep dive and more information on this. We'll have a separate webinar in about a month or so to talk about multiple sites, because we really want to dig into the different scenarios associated with that. So that's, we've gotten a far way, and we've got a lot of best practices. Look, we got 11, we got another one. Actually 10, which is, you know, I mentioned the switches and they be able to identify what's going on in your environment. Don't fly blind. Go out and get cloud vision from Arista or the Prism, which is kind of the staple in the industry for analyzing not only PTP, but it analyzes the traffic itself. It can do a lot of debugging on there, and because it is a device that does joins and it has a couple of 10 gig ports on it, I'm sorry, 25 gig ports on it, you can actually join the streams themselves and analyze if you've got some issues with the actual stream. Is the audio encoded right? How many channels do you have? So the Prism does a lot of interesting things beyond just PTP analysis. So that's what best practice number 10 is. Don't fly blind, have tools. It's kind of like, I like to go to Home Depot, you know, every weekend, just so I can build up my toolkit. Sonny, my significant other, hates it because she's like, don't you already have a pair of pliers? I'm like, yeah, but these are special pliers, you know, so, you know, you want to have the special tools. And then best practice number 11, verify the configuration. We talked a little bit about that. So it's one of these trust but verify. With the tools, you can verify very quickly across the switches, across the entire environment, that you are locked to the same grandmaster ID, that you've got your domains right. There's other tools built into the switch itself. This is kind of an eye chart here. You can see when joins and leaves happen. You can show PTP monitor. We'll show you your offset from master and any variation. So if you happen to have a device that is having a challenge locking, you may want to look at PTP monitor to make sure that that particular interface is got the right variation and path delay involved. And then on the switch itself, you could actually look at the data rates. Remember, I showed you that chart that showed, you know, what HD and standard definition and UHD were. If you can just calculate that in your head, you can say, oh, you know what, I'm sending 1 HD, I'm sending 2 HDs, and you can calculate that very quickly just to know that your media is actually flowing as well. So not only PTP, but the media itself. And worst, basically, if push comes to shove, worst case, you can even do TCP dump, which is the ability to do like a Wireshark locally on the switch, and then just capture some ports and figure out, hey, is, you know, on a particular stream, is the TTL greater than 1? Are PTP messages going out on there? Well, you know, and on which ports? So that was a lot of information that we've covered in a short amount of time. And I want to leave room for questions now. Gina, are you still on?
Yeah. So Robert, actually, if you could just go back 2 slides, I just want to emphasize one other thing, sort of our best practice number. One more slide, yeah. So on best practice number 2 there, where we say sort of use the default. So just a quick clarification there is, yep, that slide there. So there is a new version of 2059-2 coming, which incorporates the sort of feedback or the unification we had with the AES67 and SMPTE, which was the AES67 R16 recommendation. So just to review here, so that the parameters which we recommend then are an announce interval of 0, which is 1 message per second, a sync interval of -3 or 8 messages per second. These values here have been tested at sort of at the JTM tested event. They've been used at many sort of interops and these various dirty hands events, and they're deployed very heavily in the industry. So I mean, every situation is a little bit differently, but basically there's not a lot of good reasons why you'd ever want to deviate from those recommended values, which are going to be the defaults. They said they are very widely tested. We put a lot of thought into trying to compromise between lock time and message rates and stuff. And so a lot of effort's gone in. So sort of strongly recommend for like best practice number 2 to keep to those default values. Back to you, Robert.
That's good. So for our moderators, or Gina, are there any questions that we should be taking live?
We do have a number of people asking, and certainly I love the enthusiasm. So it's about the ATD multicast that you mentioned, Robert. Is that available to download from the website, or do they need to register? What's the best way to go about getting that?
Contact your Arista local person, and what we will do is we will set this up. And if we can get a good group of people to work together, it's always good to do it in groups, because quite frankly, you learn as a team. But you have that ability to do that hands-on. And what we can do is work with you to schedule that either individual basis or something like that. So it's not something you go out and register. Talk to your local account team and they'll set one up. Typically this could be a half a day training, an hour training, whatever you want to do, or an hour a day. You'll get access to a remote lab that's on the web. And so all you have to do is just bring yourself an open mind and a lot of coffee or tea, as the case may be, and play. So
that
it's
sounds
typically
fantastic.
SE driven. Mm-hmm. Yep.
That's
what
great.
else?
Well, actually, our team behind the scenes here, our Q&A team, has done a fantastic job. We've had lots of engagement, lots of questions that we've gone through and answered individually. So to our Q&A team behind the scenes, thank you very much for that. The Q&A window is still open. It'll be open for a bit if you want to get some stuff in there. Anything we can't get to today, we'll of course follow up. Common question that we're getting asked for is a copy of the slides and the recording. Yes, we will make those available. We are working on putting together a package that encompasses all three of the events that we've been going through. So look for an email. If you registered for any of our events, we'll be sending out emails to let you know when and where you can view that material online. Lots of great details to review these fantastic slides. I know there's a lot of detail in here, so absolutely, I understand people looking to get a hold of it again. So we will make those available. So look for that in the next little while. We're basically at the top of the hour. Sorry, Robert, did you have something there?
I was going to say,
Yeah.
we have, I think we have time for one more bonus thing. This is one we weren't going to show because we thought we were going to run out of time. But there's this idea of a management message loop. And we actually saw this in one of the interops originally. In fact, we updated the standard during one of the interops as we saw this. In the IEEE standard, it says that there's management messages and the devices are supposed to respond to the management messages. Well, if you think about that multicast thing before, so if you've got an end node here and he gets a management message, he's going to respond to that management message, and that management message could go everywhere. So we changed the standard after we did, oh, well, we should definitely take that one out. Remember that, guys? That was a fun day. Management message was basically denial of service, but they were following the standard at the time. Or what we were working on. And then there's another thing called management message loop between two switches. And this is something we recognized early on because we're supposed to respond to management messages, just like we were talking about in the SIPD standard. So following the IEEE. What we've since done in the last version of code over about, I guess it's about 8 months now, I think, Gerard and Ryan, is that we've got this management message loop out. So we're no longer responding to management messages. Now, there are still some switches, not Arista, that are out there that are actually, you'll see a management message storm, and they're going to come out with something like a TTL of 64, which means you're going to decrement, you're going to send that management message and acknowledge and then decrement the TTL. So you get 64 messages. And that message is, sometimes like once per second. So you're going to have a lot of throwaway. And the more that you don't have something that does this, the more or the worse your PTP is going to be, because the engine in the switches is trying to process that management message as well as the delay request, delay response, sync follow-up messages. So hopefully that made sense, which is that yes, the vendors are listening. Yes, the vendors are working on the standards and enhancing them. And yes, this is very, very stable for you to do.
Yeah, one question, so building on that a little bit, one question I saw in the chat was someone asked what has changed in the -2 standard, and I'll say for the most part, nothing too radical. As you read through it, there was some language which wasn't as clear to all implementers, and there's a few modes which were basically not used by anybody. So the changes in -2 are not, they're not radical, they're not like everything's backwards compatible. The biggest change, which is not it's an important change, but it's not that radical, is that just the recommended default values have changed. That's probably the biggest change, as well as just sort of clarification of some language and just sort of taking feedback. As at these interops, we've had like 50, 60 vendors all implementing this, and not everyone sort of interpreted everything identically. And so we're just crisping up some of the language.
Yeah, and that's an interesting thing as well too. Instead of just writing the standards and hoping that it works, we've changed. SMPTE's changed through JTNM and VSF and AMWA and AIMS and all the organizations getting together, is testing out the standards, making sure that they work and actually can be implemented before we actually commit them to stone, so to speak, and publish them. So with that, Gina, I think we're done.
You want to sort of just reinforce the next presentation?
Yeah, thank you very much, Robert. Super detailed review today, and Mike and Lee for your weigh-in as well. Special thanks to our busy Q&A team working in the background. Again, we had some great engagement today from our audience, so thank you all for attending, and we look forward to seeing you one more time next week on Wednesday, August 26th, where we will be looking at PTP commissioning and troubleshooting to round this whole thing out. So thank you all for being with us today, and of course, if you would like more information about PTP, applications, products, and demos, we invite you to reach out to our teams at arista.com, imaginecommunications.com, and telstream.net. And with that, we'll sign off and hope you have a fantastic day. Take care.